I wonder if anyone would be brave enough to volunteer any comment on this. Do you find it interesting too? What do you notice about it? Yes?
It's full. There are the two triangles. One that's, you see the black, made up of black lines, and the one that's out of the absence of lines.
Yeah, right, the absence. So anyone else want to add to the, yes?
Well, I see it that it makes a star when you put those two strings together.
Yeah. So what I put this on originally, and only in my final look at that a few minutes ago did I really realize what I thought was cool about it, which is that there is no triangle that is created in your mind. If you were to ask a computer, tell me the size of that triangle, the answer would come back, what triangle, right? This is something we do as humans, like we look for patterns, even if they're not there. And I thought this was a cool way to start off, because it's really the little short journey we're about to go on through mathematics is about finding out what patterns are true and what are not. And this is a great one where not only do we see it, but as we journey and talk about triangles, 4,000 years ago, the people who developed the facts and relationship to triangles also see that. We have this kind of hidden connection. It also highlights one pretty profound thing about math, which is every single piece of it exists only in our imagination. There is no such thing as a perfect triangle, a perfect circle, except in our imaginations, going all the way back 5,000 years. It's a pretty fascinating, I don't know, it just interests me. So if you were to ask this question, and I failed at answering it when I asked it on myself, so I want you to be brave. How would you answer the question, what is area? Would anyone guess and volunteer? And yes?
A defined space.
Okay. Let me write that down, define space. Anything else? Well, intuitively, what would we say about these? If you had to just say one fact about those two pictures.
The one on the left is bigger.
The one on the left takes up more space or more area. And so that really cuts to the essence of area is area doesn't mean anything unless it's in relation to something. Yeah. Yes, it is perspective, right? You move far enough away or close enough, and this thing can become that size.
Not only that, but you can also draw lines and come to a point where the point of perspective is from way out here to come back out and show that part up there.
Yeah.
So it's a lot of perspective.
Yeah.
And if you added some numbers to show scale, you can make them both the same size.
Right, that's very good. Yes, exactly, scale. So basically, if we want to give a value to area, we need a reference. And it's something that's so familiar to all of us, we forget that we even are doing the reference. But so let's collect a unit reference. Let's say that this is our unit reference. Now we can start talking about area, right? We have our unit reference, and now we can actually assign a value to this area, and it will mean something. But so I mean, how would you describe the area of this? It's exactly 6 units, and it could be feet, it could be millimeters, right? That's part of the familiarity causing confusion. We know it so well. Okay, so, and then how about this? The area, how would you describe that area? Yeah, it's 12 units. you could say three, 3 times 4. What it happens is you're seeing a pattern. Now I'm going to digress just shortly, because when I drew that 3 by 12, I also thought of this. If I only own 3 shirts, and I'm pretty close to that, and 4 different pair of pants, how many different outfits can I have? How many different outfits can you see me in? Yeah, yes, 12, right? And so why did I add this in? It's a little digression because I just saw the connection to probability in there, in the same thing. And thank you for indulging me. I just had to do that. So, but let's get back to area though. So when I look at this, everything looks kind of clean and easy. The first question that came to my mind was, will it still work if one of the sides is not so pleasant a number, 3.1, 3.75? And I have to admit, it wasn't immediately apparent whether or not it would work, and I had to draw a picture. It's totally understandable why you would think that having a decimal or unfriendly number might change the thing. But when you look at it, you actually say, hey, it still works. And not only that, by asking the question, something else came up in that, well, we can have 4 groups of 3.5, or we can say, I want to do the easy part first. 4 groups of 3 and 4 groups of 1/2. And why that's cool is we call it the distributive property, but it just comes up over and over again in all of arithmetic and all of algebra. And it really just occurred from asking the question, will my nice little formula hold up if it's 3.5 instead of 3? And so we can stop drawing the grid lines because we now know what we mean. And so the area of this would be, you can yell out if you want to be kind. Yeah. And we can rotate that. And there's another cool thing. It doesn't matter, right? And so what does that lead to? If I go back, it's still the same area. And this leads to another thing that I was surprised about. You're going to see that I'm surprised by a lot of things, is that order doesn't matter in multiplication, right? That's sort of our little explanation to ourselves. Order can't matter. You flip it over, it's the same area. I know when I'm putting on my shoes, order matters. I got to put my socks on before my shoes. And that's sort of my little explanation of why I was confused by this. So this is true. However, I found something that, well, let me just go and explain right here. If you're thinking about page views, it is true that 100 people visiting your web page 3 times and 3 people visiting it 100 times is the same number. You have 300 web views and 300 web views. But in this case, it's not really equal, right? This website maybe is much better. It attracts 100 different people, sort of probably maybe what you want, where this one might be 3 family members or friends. So I think I'd like to add a qualification, which is order doesn't matter if all you care about is the final value, right? It's sort of the hidden caveat underneath the question, right? I think, in school you're drilled 3 times 10 and 10 times 3, they're equal. Well, they are if you're only asking for the value of the area or the value of the multiplication of them together. So I thought that was cool as well. But again, let's get back to the area. Okay, so we're not interested in a particular rectangle. Now we're interested in every single rectangle that has ever existed. And what would be the area of this? We'll call the base B and the height H so that it can be any size rectangle we want. And the area would be base times height, right? And you could have been told the formula when you first saw it, and it wouldn't mean the same as when we built it up right here. Now you can explain it, both to yourself again and to someone else. And so far in the halfway point, I'd just like to summarize just on a little discussion or even just playing around. We sort of hit on geometry, arithmetic, algebra, probability, and logic. And I drew these separate because this is sort of how they're presented to us as separate subjects. But what I'd like to shift to is that it's really more like this. They are so intertwined that we can't pull it apart. And that perhaps it makes more sense when we accept that there is an interconnection in every point. And maybe we'll try to, in the second half, we'll try to fill in that web a little more. So let's look at a different shape. How much of that rectangle do you think that blue triangle takes up? About half. That's a good, let me write that there. Any other comments? No. Yeah, I first saw the picture and I thought it was 2/3. So how would you, anyone have a suggestion on how to know exactly what that area is? Yes?
If you draw a vertical line from the top of
Yeah.
the blue down,
You mean like this?
yeah, like that. Then it,
That's a great idea. And then you see it. Does anyone else see it that has not seen it before? Did it first come into the picture? Okay, so suddenly, we just go back here. I'm looking at it thinking it's 2/3, or I'm actually was thinking, I was asked this question and I didn't really want to answer it. Because, and again, I believe I'm so familiar with rectangles and triangles, but so once that dotted line is drawn, you can feel confident you know exactly how much area that takes up, right? What about if we move, let's look at this. What about that shape? It's still the same, right? No one's once that dotted line got imprinted in your brain, you're like a little pattern machine that adds the dotted line without me. So that one doesn't trick you either. So it's a great pattern. And also it's sort of the discovery. This is a 3,700-year-old moment where we join the Babylonians in discovering how to get the area of any triangle in a rectangle. So it's cool. Now, if you didn't know, if you were just told the formula ahead of time, you might have been deprived of such a fun and joyful little image. The other thing that's cool about it is that you now got a glimpse of where the logic is in there's a statement out there that says every piece of mathematics is underlain with logic. So there is logic at the foundation of every single piece. And it's a pretty profound statement. At first, when I read it, I was like, is it? I kind of was a little skeptical. But here, you can see it clearly when you got to explain to someone why this triangle takes up exactly the rectangle. You could go through this thought process and realize that logic is inside that formula. I'll leave that as an activity for you guys to mess with on your own. Okay, one more shape, if you have the energy. And from the smiles, I say yes, we want one more. Okay, so this is a parallelogram. The opposite sides are parallel. That's why it's called a parallelogram. What is the area of that shape? Say it again. Base times height. So now you can see the answer, but the real answer is the explanation. Why? Why?
Had something that you could actually cut and
Yeah.
move.
You want to
see
cut
that
something
the
there?
triangle on the left would fit into the missing piece.
Do you want me to cut that piece off?
That'd be great.
Do you want me to move it over there?
Whichever piece you want to cut off.
Your ability to move images is fantastic. Yeah, so, right, once you this is beautiful. No more needs to be said. Again, I was surprised by this. I'm sort of slow. You can catch on to it. This surprise, they don't look the same to me. But then I did what Jackie said, and I looked at it and said, nope, they don't fit. Oh, but I'm going to move the piece just like you wanted. And the reason why I added the parallelogram, we're almost nearing the end of our wonderful time together. The reason why I chose the parallelogram is it brings up a huge theme in modeling and calculus. Yes, I get to add them to the web now, which is you start getting a complicated problem. See if you can solve it by making it something simpler, and a rectangle is the greatest thing. And so you'll see when we get to calculus, what underlies everything is about making a crazy shape into something simple and easy like a rectangle. Yes, so I think I hit on that. In addition to it being a cool shape that's simple and beautiful, it highlighted the point of modeling, which is you have something complex, see if you can solve the simpler version. Does it reveal the solution of your original complex portion? Okay, so here we added calculus and modeling. I could have added computer science in there. We'll talk about that next time, where the computer science was in that. So here they are. Here's the formulas. We don't ever need to have anyone memorize them anymore because you can just now regenerate them and explain them. And although these are simple formulas, the next layer of procedures that you need to memorize, we can also break down until a point where you can show up and you don't need to memorize anything. That's hopefully the goal. Why is that the goal? Because that's when you have the most fun, in my opinion. But I'm going to leave you with a gift. We're in our final minute here. And this one's all for you. Take a picture with your cell phone if you would like. Right, this is the gift, and you don't have to accept it. What happens? You guys were lightning quick on what happens if I move the point up here. What happens if I move it outside that rectangle? And again, the answer here is really not the formula of the triangle, but the explanation. That's where things will really happen. So it's all for you. There's no due date, no pressure. I'd love for you to photograph and work on it if you're interested. Don't worry how long it takes you, if it takes 60 seconds or 3 weeks. This problem probably took 300 or 400 years. Most problems take thousands of years to solve in math. And most of our problems in math haven't even been solved yet. So thank you very much. And we'll see you next time.